So hey guys, welcome back to my channel. Hope you're doing extremely well. This is your very own mascot of this site, and today we will be solving another POTD. So today's POTD is asked in Amazon and Google, and it is known as distinct occurrences. It is a medium type problem. Let us see what does the problem states. Okay, so the problem states that you have been given two strings S and T. In this case, S is banana and T is ban. Okay, now we have to find distinct occurrences of T in S. Distinct occurrences of T in S. As in, how many times T is occurring in S as a subsequence. T is occurring in S as a subsequence. All right. Okay, so let us see. So if we see a subsequence is, if we state all the subsequences like BAN, it is coming here, BAN, okay, and then it is coming as BA, then N here, another subsequence, then it is coming as, uh, I guess only this, no, then only B with A with N, sorry, this A with this N, right? Okay, so if you see the example, it's the same example. You can see output is 3, that is either you choose the first three letters or you choose the first two letters with this N, or you choose the first letter with this an. Okay, these are the three subsequences that are possible to make T out of S. Okay, so I think all of you know about distinct subsequences, like sorry, it is not distinct, all the subsequences of a string. So it will work like the brute force method will be, this is the brute force first method. The brute force first method is find all the subsequence of S. After that, compare each subsequence if equals to T, right? Then if equals to T, then return, then answer plus plus. Okay. These are the two steps in the brute force method. I'm not explaining how to find the subsequences. I think all of you might know. We choose a take not take approach. Take not take approach. And before you guys watch any more further, I would suggest you to go have a look on the subsequence video. How to find the subsequence of a string. Okay. To find out the subsequence of S, it will take us the time of O of to the power n time complexity, that is exponential time complexity, and it will be taking answer plus plus. It will be taking, suppose there are n strings, right? N characters. So and the number of strings that will be formed is 2 to the power n only. So it will also be taking O of 2 to the power n to check. Okay. So very inefficient. The brute force 2 suggests, is there some way to skip the second step? Like this was divided in first step and second step. Is there some way to skip the second step? Like we don't have to check all the combinations together. I say yes. What do we do? When finding all the subsequences, we apply the condition that S should be equals to T. The subsequent should be equals to T. We will see how. For that, what we will do is, suppose we are standing at B, A, N, A, N, A, right? Let me mark the indexes 0, 1, 2, 3, 4, 5. And T is B, A, N, right? 0, 1, 2. I will say, start your recursion from 0 to 0, 0, comma 0. That is, S letter is also 0, B letter is also 0. Okay. You say, okay, no problem. Then I say, if Si, that is S0, is equals to Tj, that is, this is representing my I, this is representing my J, okay, is equals to Tj, that is B here. Yes, they are equal. There are two cases. Either you choose this B or you disrespect this B. Like you don't choose this B or you choose this B. If you choose this B, then J will move forward. Like if you choose this B, then J will move forward. J will move to A, that is index 1. I will have to move forward if you choose or not choose. Okay, 1 comma 1. Another case is I moved, but you didn't choose, so B doesn't move, J doesn't move. Okay, 1 comma 0. Two sub cases, right? Now moving to A. Now one is A and 0 is b, not equal. The only case you can use here is to not choose, so it will move to 2 0, right? Then 2 2 0, as n equals to b, no, 3 0. Is a equals to b, no, 4 0. Is n equals to b, no, 5 0. Is a equals to b, no, 6 0. Now you will see the length of s is finished, so it will return false to this, 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 false, right? The case left with us is 1 comma 1. We have to explore this case only now. So 1 comma 1, a equals to a, yes, two subcases right now. What is the subcase? Either you choose this a or you don't choose this a. If you choose this a, then 2 comma 2. If you don't choose, 2 comma 1 remains. Okay, solving for 2 comma 1. So we are standing at n and we have to check for a. Is n equals to a? No, go to 3 comma 1. Is a equals to a? Yes. So again, two subcases. You don't choose, that is 4 comma 1, or you choose, that is 4 comma 2. Okay, if you don't choose, then 4 comma 1. N is equals to a? No, go to 5 comma 1. Then a equals to a? Yes, again two cases. Either you choose this, so it will be what do we say, yeah, 6 comma 2, or you don't choose this, so 6 comma 1. In both the cases you will observe we have reached the end of the string s, but we have not reached the end of string t. In that case it will return false, because if we have reached the end of the string s, it is impossible for me to find the t in the further process, right? So it is returning false from both of the sides, that is 0. In the sense false is 0, number of strings we are returning, right? 0 0, it will return 0 here. Okay, 4 comma 1 will return 0. 3 comma 1 had one remaining case, that is 4 comma 2, that is n to n. Okay, are they matching? Yes. So again two cases, either I choose this or I don't choose this. If I don't choose this, then it will go to 5 comma 2. If I choose no, if I choose it, it will go to 5 comma 3. Now when I go to 5 comma 3, I see length of t is completed, that means 5 comma 3 is a valid subsequence, it will return 1. But 5 comma 2, a map to n, not possible, it will go to 6 comma 2. And as you can see, 6 comma 2 was here also returning 0. So we have found an overlapping case. Overlapping, that means whenever I found overlapping, then dynamic programming is possible. Okay, 6 comma 2, again it will return 0. 5 comma 2 will return 0. 0 plus 1 now is 1, so it will be returning 1. And 0 plus 1 is 1, so it will be returning 1. Now it will return 1. 2 comma 1 will return 1. The only case left is 2 comma 2. We have to explore 2 comma 2. So 2 is here, that is n. 2 comma 2 is 2. Okay, it should be returning what do we say, two subcases now, because n is equals to n, so it can choose this n. In that case 3 comma 2 and 3 comma 3, right? I hope you are following the recursion subtree. 3 comma 2 or 3 comma 3. So 3 comma 2, that is a mapped to n? No, go to 4 comma 2. Now when you will go to, as soon as you go to 4 comma 2, you will observe 4 comma 2 is already done. And if it is already done, I will not do this again, I will just use a dp array, and it is returning 1. Okay, return 1. 3 comma 3, you will see that length of n is length of t is finished, because length of t is 3 only, it will return 1. Now 1, it is also reading 1 plus 1, it will return 2. 1 plus 2, it will return 3. And this was my starting call, so it will be returning me 3, and which is our answer. You observed in the cases that it is our answer. Okay. So this was a recursive subtree. This is the algorithm we are going to use. Let me write the pseudo code for you. What we will be doing is we will be making a function solve, and we will be sending the string t I j. Right? I is for s, T is for J, or J is for T. Okay. Now if T dot length equals to J, that we have reached the end of T. In that case, return 1. Simple. If s dot length is equals to I. Now, now guys, see, it is reaching this statement only because if this statement was not executed, right? So if this statement is not executed and s length is equals to I, that means s is finished. In that case, we have to return zero because it is impossible for me to make t out of s now, right? Remaining s now. Okay, return zero. Okay, now two sub cases. If si equals to tj, in that case, two subcases are possible. Either we take it or not take it. So implement the take, that is I plus 1 j plus 1, or not take, that is I plus 1 with j. Correct? And then return the sum of all these, the sum of both, right? Else, if they're not equal, then the only option is to not take, right? We cannot take a part which is not equal. So I plus 1 j, and then return, right? If it is here, go return this statement. If it is here, then return this statement. We will apply the dp in the metric code itself. So let us look at the code. In the meantime, if you're new here, please subscribe to my channel because it helps me get a lot of motivation that you guys are liking my video. Okay, so subsequence count is the problem's name. So what I will do is, I will start from I will say vector of, oh, let me make the length also. So in 10 equals to s dot length, in 10 equals to t dot length. All right, so let me make a dp array, vector of vector int and deep, oh sorry, only dp. Size of dp array is n comma vector of int m initialized with -1. This is the standard procedure for a dp array, right? Now I will say return whatever you get from solve function, and solve function will be taking as my t, my starting index is at a 0 comma 0 and my dp array, right? Also, bus, this is the thing for the driver function. Now we have to implement a solve function. It is returning int, so int solve string s string t int I int j, and then vector of vector int and dp, right? Okay, first sub case is if t dot length is equals to j. In that case, t is finished. We have found a perfect subsequence. In that case, return 1. Otherwise, if s dot length is equals to 1, is equals to I, that means s is finished, but t is not in our hands, right? In that case, return 0. Now, if si equals to tj, that is, we can either take or not take. In that case, return dpij equals to solve of s t I plus 1 j plus 1 dp plus solve of s t I plus 1 j dp. First one is for taking, second one is for not taking, right? Else, if they are not equal, then the only option we have is to not take. In that case, return dpij equals to solve for s t I plus 1 j and dp. Okay, these are the two sub cases only. Now, if you see the question, it is saying modulo of 10 to the power 9 plus 7. So I will have to take the mod also. Pretty simple. I will calculate mod everywhere. So mod equals to 1a9 plus 7. So where am I getting values? I am getting values at solve. So it will be solve percentile mod, solve percentile mod, solve percentile mod, and here also solve percentile mod, right? So I think this should work fine. Let us see in the compile and run process. In the meantime, if you're new here, please subscribe to my channel and let us try for submit also. If you're liking the video, if you've got the concept correct, then please do like the video, and not and if not, then return the basic mistake I have done. Can you anyone spot that? If yes, please comment down. I've made the dp array, but I've not used this. Sorry, if dpij is not equals to -1, in that case return dpij. Sorry for my mistake, guys. Hope you were able to find it and do not commit it. Okay, so running fine. Let's try for submit also. So we have completed a 69 days streak, and that means a lot to me. So please like this video, subscribe to my channel, and if you have any doubts or just want to appreciate me, then please do comments, because it really gives me a lot of motivation. Okay, thank you. Have a nice day. We'll meet tomorrow. Till then, keep coding.